All right, section 11.8, surface area and volumes of spheres. Okay, so our objective for this lesson is to find surface areas of spheres and volumes of spheres. Again, surface area is the area of the surface. And that's kind of a difficult concept to think of when it comes to a sphere because it's not a nice polygon. Just think about like any type of ball, a basketball, a soccer ball, and you deflate it and you're just looking at the material that makes up the outside. Okay, what's the area of that? Okay, so first let's talk a little bit of vocabulary. Okay. So a little bit of vocabulary. When we talk about a chord of a sphere, a chord of a sphere is just a segment. A segment with endpoints on the sphere. So it's kind of hard to visualize it 2D because it is a 3D idea, but if you see here, this chord right here, think of it as a segment that's inside this sphere, that this endpoint is on the front of the sphere, this endpoint's on the back side of the sphere, so the chord is now inside that sphere. Okay, it's not on the sphere. It doesn't go on the outside of the sphere. The segment actually lies inside that sphere somewhere. Okay, so then the diameter here across the middle of the sphere, this longest, is actually the biggest chord that will fit inside the sphere. Okay, so to help us find that diameter, we need to find what is called the great circle. And that's actually the circle that we denote here in the picture. It's really the biggest circle you can create when you have a plane. Do you see our plane here cutting through our circle? Okay, so if this plane, so when you have this plane, a plane intersecting a sphere, through its center. So it goes through the center of the circle right there. It goes through the center of the sphere, that little center right there. It goes through that center, okay? A plane intersecting a sphere through its center, the intersection of that plane, of the plane and the sphere, is called the great circle of the sphere. Okay, so here, if again I have this plane, it cuts through my sphere, it intersects through my sphere, and it goes through the center of that sphere. So then that circle that's created, this circle right here, is what we call that great circle. Okay, just a little bit of vocabulary there. Okay, so now if I want to find the surface area and volume of a sphere, I love the equations for surface area and volume of a sphere. What makes a sphere so nice is a sphere really only has one dimension, and that is the radius of the sphere. The whole entire size of the sphere comes from one dimension, that radius. If the radius is small, the sphere will be small. If the radius is big, the sphere will be big. That's the only dimension that a sphere has, is the size of that radius. So all of its equations are based on that radius. So to find the surface area of a sphere, the surface area of a sphere here, surface area, is equal to 4 pi times r squared. If you notice, it's the same as the area of a circle, except it's 4 of them. Okay, so really, because this bit right here, that bit there, this bit right here, this thing right here, is just the area of a circle, pi r squared. So the surface area of a sphere is 4 of those, 4 pi r squared. Okay. So basically, whatever the area of this great circle is here in the middle, the area of this circle, The surface area is 4 of them. Okay, so if I want to find the surface area of each sphere. Okay, so this first one, it gives me that radius, so that's nice. It gives me my radius here is 8, so let's mark that as the radius. So here's my radius, is right there, 8 inches. So the surface area is equal to 4 pi r squared. So 4 times pi times my radius, which is 8 squared. So it'd be 4 times pi. 8 squared is 64. So take 4 times 64. We get 256 pi. And my units, it's area, so it would be up here the inches. So it'd be inches squared. So my area is 256 pi inches squared. I can then find the approximately. 256 pi is approximately 804.2 square inches. So there's the exact and there's the approximately. All right. All right, next one. Okay, this is part B. They tell me the circumference of that great circle, C circumference, is 12 pi feet. So we have to remember from previously circumference. How do I find circumference? Circumference is equal to 2 pi times the r. So I know my circumference here is 12. So let's replace that C with a 12. So we'd have 12 pi equals 2 pi r. So here going on between the two, the pi and the r, those are all multiply. So to undo those, I can divide by a 2 and a pi. 2's, that's 1. 2 divided by 2 is 1. Pi divided by pi is 1. So here I have 1r. And let's see, pi divided by pi is 1. 12 divided by 2 is 6. So my radius is 6. So since my radius is 6, now I can find the surface area. My surface area equals 4 pi r squared. So 4 pi times 6 squared. So 4 pi times 36. So let's take the 36 times 4. We get 144 pi. My units here, we're dealing with feet. So my units would be feet squared, which is approximately 44 pi, 452.4 square feet. So there's my approximately and my exact. Okay, so there's surface area of a sphere. Okay. All right, here's a slightly different problem. Find the diameter of the sphere. When they tell us here, my surface area is 20.25 pi, and we're trying to find the diameter. So don't lose track, we're trying to find the diameter. The diameter is what? Okay, and if you remember, a diameter is 2 radii. So let's use the surface area formula for pi r to find the radius. Because I know that this here is the surface area, so let's replace it for my s right there. So we'd have 20.25 pi equals 4 pi r. Again, between the 4 and the pi and the r, those are all multiply, multiply, multiply. So let's divide both sides by 4 and pi. 4 divided by 4 is 1, pi divided by pi is 1. Pi divided by pi there is 1, so I need to take 20.25 and divide it by 4. I get 5.0625. That's no rounding at all, so that's exact, which as a fraction, 81 over 16. So there's the two versions of the radius. The diameter is equal to 2 radii, so take 2 times the 5.0625. I haven't my calculator, so just times 2. Okay, as a fraction, my diameter is 81 over 8, or as a decimal, 10.125. So there is my diameter. Okay, surface area. Now volume. The volume of a sphere. Again, a sphere only has that one dimension, that radius. So the volume is equal to 4/3 pi r cubed. This equation comes from somewhere. It's not just out of thin air. It's just above us right now to figure out where that's from. So again, it's volume, so it makes sense that it would be cubed. And then really just kind of remembering it's 4/3 pi r cubed, so it's 4/3 pi r cubed is the volume of a sphere. Okay, so that would be something useful to remember for the test, knowing the volume of a sphere is 4/3 pi r cubed. Okay, so we want to find the volume of the soccer ball. They give us here 4.5 inches, that's the radius of that great circle. So this guy right here is my r. So my volume of a sphere is 4/3 pi r cubed. So we take 4/3 times pi times my radius, which is 4.5, and we cube that. So let's take 4.5 and cube it. We get 91.125. Okay, so 4/3 pi times that. Let's multiply. So I'm going to multiply that 91.125, this thing right here, times the 4/3. Times, let's see, 4/3. And we get 121.5. But then I still have to multiply it times that pi right there, so times pi. And that is my volume, and that would be my units is inches. So volume be inches cubed. So there's my exact volume. My approximate then would be the 121.5 times pi, 381.7 cubic inches. And there's my approximately. Okay. One more example. The surface area of a sphere is 324 pi square centimeters. So let's write that down. My surface area, which is S, is 324 pi square centimeters, so centimeters squared. Find the volume. So we want to try to find that volume. Okay, so to find the volume, again, the equation for volume is 4/3 pi r cubed. So to find volume, I need to know my r. So let's use the surface area formula. Surface area is 4 pi r squared, and let's find r. So we know this guy right here is my surface area, so let's replace that for my S. So we'd have 324 pi equals 4 pi r squared. Again, between the pi and the r squared is multiplies, so to undo multiplies we need to divide. 4 divided by 4, pi divided by pi. Here, pi divided by, undo. Pi divided by pi is 1, so I need to take 324 divided by 4. So r squared is 81. So when I square root both sides, that means my r is equal to 9. So we now know my radius is 9. So now I can plug it over into my volume formula. 4/3 pi 9 cubed. So take 9 and cube it. 729. So 4/3 pi times 729. I'm going to take this 729, multiply it by the 4/3. We get 972 pi. And my units, it's volume, my units would be centimeters cubed. So let's do approximately 3,053.6 cubic centimeters. So there's the exact and there's the approximate.